Okay, question 5 is asking you about graphene and diamond, and it tells you their forms of carbons. So this topic is allotropes if you are looking this up for a bit more revision. So draw a diagram to show the structure of graphene layer. So graphene is basically one sheet, one layer of graphite, which you might be more familiar with. And they just want you to draw a minimum of two of the hexagonal shapes to show its structure. Now, they then ask you to estimate the approximate thickness of graphene layer in meters. What they want you to know is that nanoparticles are at 10 to the minus 10 meters. The precise thickness of graphene is 3.4 times 10 to the minus 10, but they would accepted pretty much any number in the 1 to 9 times 10 to the minus 10 range. Okay? Right, explain why graphene does conduct electricity, but diamond does not conduct electricity. If you are talking about conduct electricity, one of your first thoughts should be about delocalized electrons. So, graphene does conduct electricity. It has delocalized electrons present, and diamond does not. They want that comparison. So, the delocalization, I'll repeat that, the delocalized electrons can carry the current or the charge throughout the structure. So they're giving you a mark for saying that they're delocalized electron and diamond doesn't have them. That's key. They give you a mark for saying those electrons carry charge. And the third mark is saying they can move through the structure. Okay, it's really, really key when they're talking about conductivity of electricity, that it can move through the structure. Right, the final part of question, or the final two parts of question 5, it says, explain why diamond has a high melting point. Answer in terms of structure and bonding of diamond. This is a classic question. They love this one. And they might ask about a graphite too, a similar question. So, it has a giant structure. Now we look at the model in class and it's quite small, but it is millions and billions of atoms joined together. Those bonds are covalent bonds, okay? And those bonds are very strong. So, if they're very strong and lots of them, you're going to need a lot of energy to break them up. Okay, there are key points there. Right, final part of question 5. Fullerenes are also forms of carbon. Give two differences between the structure of fullerenes and graphene. So fullerenes are things like the buckyball or those nanotubes you will have looked at. So fullerenes can have rings and they've got 5-7 carbon atoms on. And they also have a hollow or spherical shape. This makes them good for use in delivering medicines potentially. It's a big area being developed. Right, that's question 5 and it looks like the bell's gone, so I'm going to pause there.